Hello, my name is Patrick, and today I'm going to talk about our work, Can Machines Help Us Answering question 16 in Datasheets, and in turn, reflecting on inappropriate content, which focuses on documenting inappropriate content of vision datasets. As you can see, our work is inspired by datasheets for datasets. Datasheets encourage to reflect on the composition of datasets. The goal is to increase transparency and accountability within the machine learning community and help users select more appropriate datasets for their chosen tasks. With our work, we focus on a semi-automated approach to answer question 16 in datasheets. Does a dataset contain data that, if viewed directly, might be offensive, insulting, threatening, or might otherwise cause anxiety, which we summarize as inappropriate content? But before I will introduce you to our approach, let me illustrate why documenting datasets is so important for not only the dataset creators, but also users. So people who want to train a specific model and look for appropriate datasets, and also users who want to use a pre-trained model. We know of several issues of large-scale models. One is based on the fact that you need a huge amount of data to train these models. And in most cases, these datasets are under-curated. For example, this generative model here is trained on uncurated dataset containing hundreds of million text and image pairs. It enables us to generate images by prompting text. For example, soul. So if you prompt soul, you get a few images representing the training data distribution. But since we can prompt any text, we can also misuse the model to generate something offensive. For instance, something extreme like this. Luckily, we get an error message because the application prevents showing the output by validating the content of the generated images. Actually, the creators of this application use the inappropriate content detector, which is part of our Q16 approach. This works for different concepts. However, as the error message states here, if you feel your prompt was not supposed to give not safe for work outputs, this may be due to the bias in the model. So the disadvantage of such post hoc validation is that we are not able to prompt specific content which seems not offensive in nature, but the content of the related training data may suggest something else. In this case, the user should have picked another dataset or picked another pre-trained model if they want to deploy the system. Proper documentation of these datasets and dataset references for pre-trained models would help the user in these decisions. But recent machine learning datasets tend to become larger and larger, and in turn, complete manual documentation becomes unfeasible. So to assist the creators, we ask the question of whether a machine can help us reflect on inappropriate content. To this end, we propose to use the information stored in pre-trained transformer models. Our approach consists of two parts. In the first step, we make use of the pre-trained model clip as a content detection, pre-selecting potential inappropriate content. Clip is an open vocabulary image classifier. It is trained in a self-supervised fashion on a few hundreds of million text image samples, likely also on inappropriate content. Further, this model enables us to classify images based on text prompts. Due to this, we show that it's able to reflect on inappropriate content without being trained in doing so. For example, here on the right side, you see a standard PCA on embedded images using CLIP. We can see that the model can distinguish between inappropriate, here labeled as 1 and 2, and appropriate content, here labeled as 4 and 5. The dataset we see here contains different concepts of inappropriate content. In total, over 50 concepts are included, with negative ones such as harm, inequality, and discrimination, but also counterexamples, as you can see here. We further improve the performance of the classifier by applying prompt tuning using these samples. So instead tuning the model weights, we tune the text we prompt and steer the model in the direction we want. Now, given a data set, we use the steered model to detect contain potential inappropriate content. In the next step, this content should be validated by humans. To assist the human in doing so, the second step of Q16 is the documentation of the identified content. Next to the datasets annotation, we also use another large-scale pre-trained model, the caption generation model MAGMA. This model generates captions describing the identified concepts contained in the dataset. Use the generated descriptions to point the user to identified images. Regarding detection, we do not provide the first approach to detect inappropriate content. A typical example you will find in current documentation is pornographic content. However, we focus on a broader range, including, for example, not only persons, but also objects and symbols, and further concepts such as harm. Here you can see some blurred examples of the concept harm we found on ImageNet using our classifier. I won't go into details here. You can check our paper for these, but you already see that, for example, animals, objects like guns, or of course also images displaying humans are included. Later we will see how we document this content, so the user can decide, depending on the task, which images or whether the dataset at all should be used. Let's come back to our classifier. We use the mentioned dataset to evaluate CLIP and our prompt tuning approach. In particular, in our evaluation, we show that the zero-shot approach, so CLIP itself here on the right side, we can already classify about 80% of the content. You can also see that this scales with the model complexity. And with only a few samples, we get a reliable classification able to detect all selected concepts. We applied our Q16, including the detection and documentation on two popular vision datasets, ImageNet and OpenImages, and documented several, depending on the task, potential inappropriate concepts. I will refrain from showing you the images we identified, but let's look at some of the descriptions which should be included in the documentations. First, as you can see, our classifier is quite conservative and therefore detects many potential examples. Both datasets contain over 1 million samples. The identified samples should be validated by the dataset creators. Depending on the kind of class annotations, we get first insights of what is displayed. In case of ImageNet, most class annotations, however, only provide little insights. Since it is an object detection dataset, we get negative associated objects, but also something like plastic bag. The generated descriptions additionally indicate that most images show humans. Some images seem to show scenes in bathrooms, but also plastic bag again. In case of OpenImages, the class annotations already provide us with the information that most identified images show humans. The generated descriptions indicate that posters and guns are displayed. To now point users to specific inappropriate concepts, we applied an additional weighting to the descriptions by giving more weight to concepts we do not see in the corresponding appropriate subset. We visualize the most frequent descriptions as word clouds here. Potential inappropriate concepts like blood, execution, and dead body can be now traced back to the corresponding images to assist documentation. Thank you so much for listening to this talk, and you can find more details in our paper. You can also try out our code or play around with our detector on the line 5B dataset, which started off to employ our Q16 approach and provides a nice web interface to explore the dataset.